What's up, guys? Can you hear the music? I don't know if you can hear the music. We're just gonna wait a few minutes while everyone joins. I hope you can hear the music. Okay. I'm kind of excited for this one because we're gonna be using Hardhat. The last one I did, we were using Remix, and I'm not a huge fan of Remix. Actually, um, I'll answer your question, Drought, and actually, I want to introduce something. So, for someone kind of new to coding, where do you recommend to begin? JavaScript. It's all the answer is always JavaScript. Um, our level 0 in the freshman track. So, crap, I'm not logged in. Okay, let me log in. Oh god, yeah, I get nervous while live streaming. Okay, give me a sec. There we go. Okay. Cool. So yeah, so if you go down to like freshman and then you go to level 0, which is basic programming, um, we give you some background knowledge like why other things like why some Web2 skills are important, and give you some links to front end and back end development that both use JavaScript. JavaScript's really nice because like it's the only language that runs on the web on the front end, and since you can use it in backend as well, it's like less overhead. You don't have to go and learn two programming languages. You can do everything you want with just one. So yeah, dive into JavaScript for front end and back end. Get your concepts clear, and then just move on. Right? Um, you can do this. I'm sure you can find partners in the pair programming channel on Discord. I know there's a bunch of people in similar situations. Um, but yeah, hopefully that helps. Do we need JavaScript and React knowledge to get started with Solidity? Well, you don't need them to learn Solidity per se, but you need them to build functional dApps because your users are not gonna like call Solidity functions. Your users are gonna use a website, so you need JavaScript and or React knowledge to build websites that interact with your Solidity code, right? Okay. Cool. All right, give me 1 second. I'm doing something real quick, and then we'll start. All right. only for building smart contracts, yes, you don't need what's it called? JavaScript. Yes. For backend, yeah. If you're not using um, if you're not using JavaScript backends, then yes, I guess you can do without JavaScript. That's totally fine. All right, give me 1 second. Sorry, I'm just trying something. We will start very soon. All right, we'll launch and cool. Okay, so I want you guys to try and do this. We'll test this out. So messages get lost in the YouTube live stream. I want you to go to this website here and input this code. So hopefully this will be a little easier to keep track of. I'll have this window open on my second monitor, and it will be easier to keep track of questions because when I'm not on the live stream tab, I don't see your questions. Also, if someone could just post some random question there, just so I know that it's working, and then we can get started. Just share the link here. You can also use this direct link. That works better for you. Huh. What? Okay. There we go. Hey, I love you too, man. Alright, this looks like it's working. Sounds good. Okay, so it's weird. Okay, so new questions come on the top, not at the bottom. Okay, interesting. Perfect. Alright. So, let's see. Cool. Let's get started then, right? Okay. So, NFT tutorial. So this is the tutorial we're going to be doing. I should probably open it on LearnWeb3's website. So yeah, this is the tutorial we're going to be doing. We're going to build a simple smart contract that basically is an NFT. We're going to look at it on OpenSea. It's not going to have an image. That part is for sophomore, because for NFTs to have images, you need more than just Solidity code. And we'll probably do a live session on that later on, but it will be an NFT. You can look at it on OpenSea. It will just say there's no image, but it is an NFT as far as anything goes. So, all right, to get started, prerequisites, right? First things first, you need to have MetaMask. Is this big enough? Yep. First things first, you want to have MetaMask installed. So for people who are new, or this might be your first session, MetaMask is an Ethereum wallet that allows you to send transactions on Ethereum and keep your tokens safe. So you can download it. If you Google for MetaMask, you go to metamask.io. You can download it. It's compatible with like Chrome, Firefox, Opera, Edge, Brave, whatever you use, right? It's just not compatible with Safari, so sorry, Apple users, you need a second browser there. But yeah, install MetaMask, set it up, and then you should have this like tiny fox on your thing, on your browser. And what you want to do there is you want to go to, actually, are there any questions yet? Okay. How's my health? Thanks for being considered. I'm perfectly okay now. No problems. But yeah. Okay, so for MetaMask, yeah. Once you install it, once you set it up, once you have a window that looks like this, first thing you want to do is you want to switch to a test network. You want to switch to the Rinkeby test network. And to do that, if you just installed it, you might need to enable it in your settings. So to do that, go to click on your account here, go to settings on MetaMask, go to advanced, and then turn on show test networks, right? When you turn this on, then here in your list of networks, you will find Rinkeby test network. Okay, so that's the first thing you want to do. Second thing you want to do is you want to make sure your computer has Node.js installed. So Node.js is a JavaScript runtime. So you can run JavaScript on a computer. JavaScript by default only runs on the web, only runs on browsers. So Node.js is what you need to run JavaScript on your computer. Whatever operating system you're on, you can just go to nodejs.org and download the LTS version, okay? Don't download the current version. This is not stable. Current versions have the latest features, but they are not stable. They have issues, they have bugs. LTS is the stable version. Download the LTS version, okay? And you can confirm if you have Node.js installed or not by if you open a terminal window. Let me zoom in a bit. Okay. Maybe make this even smaller. All right. So hopefully this is big enough. Yeah. So assuming you have Node.js installed, you can verify that it is installed. Don't worry about that. You can. Oh shit! Sorry. You can verify that it is installed by typing node-v. So this is Node version, and you should have something like 16 point whatever. Cool. So once you do all of this, then we are good to go. All right. So let me just check the chat. Okay, perfect. We are good to go. So, all right. So let's start writing the contract. So we're going to be using Hardhat. I think Sneh already introduced it if you're on the dApp tutorial live stream. Oh, wait. Actually, no, I don't think the dApp tutorial used Hardhat. What is Hardhat? Hardhat, it's a development framework for Ethereum smart contracts. So previously we've used Remix, which was a browser editor for writing Solidity code, but Remix sucks. And you will learn that as you do more and more Solidity development. Remix is not great. Hardhat, much better, right? And it allows you to write code locally on your computer, in VS Code or whatever code editor you guys use. So we're going to be using Hardhat. So I'll just chuck this tutorial and let's walk through it ourselves. All right. So you have your terminal. In your terminal, go to wherever you want to go to. So I'll go to my desktop and create a folder to store this, right? So I'm gonna make a directory called LearnWeb3 NFT tutorial. All right. If you're on Windows, the command might be slightly different, but you can always just go to Windows Explorer and right-click new folder or whatever. Cool. So create a folder to where we'll store our code. Go into that folder, cd into that folder. And here, first thing we're going to do is we're going to set up a new Node.js project. Is Hardhat works with Node.js. So to do that, we want to do npm init, and let's just do dash dash yes. So npm is, npm is Node package manager. It, like when you install Node.js, it automatically also installs npm. We will use this to install third-party libraries such as Hardhat into our project. So npm init creates a new Node.js project, stands for initialize. So cool. Once we have that, we can go ahead and install Hardhat as a library. So to do that, let's do npm install dash dash save dev. It's a developer dependency, and type Hardhat. Okay. Give it some time to download. All right, cool. So Hardhat is installed. You'll see we now have this folder called node modules. This is where we install third-party libraries. So when you install Hardhat, it went in here. Let's open this up in VS Code, and let's see what's in there. Yes, I trust myself. All right, let me package.json. So let me zoom in the font a little bit. All right, cool. So yeah, and pretty basic, simplistic like Node.js project with one dependency, that is Hardhat, right? So we want to create a new Hardhat project so we can start writing our smart contracts. Thankfully, Hardhat makes this really easy. You can just type npx Hardhat. Note this is an X, not an M. npx is different from npm, but it's basically used to run libraries that come with executables. So just do npx Hardhat. If you're on Windows at this point, make sure you're using command prompt. If you're using PowerShell or Bash or some other third-party terminal for Windows, this will not work. Okay, Hardhat has an issue on Windows machines where it only works if you're using CMD, if you're using the command prompt. So I'm just putting it out there. Anybody on Windows, make sure you're using command prompt for this step. So when you do npx Hardhat, it'll give you a few different options. What do you want to do? We'll just choose create a basic sample project. All right, just click enter, and click enter again, and click enter again, and click enter again. Right, we want all of this. So it's going to install some more dependencies that it needs, and that's totally fine. So let's wait for that to be installed. Where is the Node.js website? Oh, Node.js. So it is nodejs.org. It's node, not no. Sorry if that wasn't clear, but let me see if I can just share the link in chat. There you go. All right. Right. While this happens, it might be good to look over what an NFT actually means. I remember in the cryptocurrency tutorial I did, I gave an explanation of what is an ERC20 token, what is a token on Ethereum in general. So there we looked at the token standard for it, and similarly, NFTs, there's actually like two NFT standards. We're gonna be using EIP 721. There's another one called EIP 1155. We won't get into that today, but let's look at what it actually means to be an NFT, right? So cryptocurrencies like Bitcoin or Ethereum or whatever are what's called fungible tokens, right? So fungible, can you see this? Okay. Fungible, the English word, means that it can be replaced. It is able to be replaced or been replaced by another item. It is mutually interchangeable, right? So what this means is money in general is fungible, right? You and I, we could have two different $1 notes, but if we exchange our $1 notes, it doesn't make a difference. It's the same thing, right? It doesn't matter that your note has a different like serial number on it or whatever, and it's like it may be in a better condition or worse condition, but it doesn't matter. $1 is $1, right? That is fungibility. So Bitcoin and Ethereum and all these tokens, they are fungible tokens. It doesn't matter if you have a Bitcoin and I have a Bitcoin. It doesn't matter if we trade those. Like, it's still one Bitcoin. Nobody cares, right? NFTs are different. In NFTs, every token is unique, right? They have certain properties where they're not replaceable. And like, how do I give you an example? So, this is probably not the best example, but like let's think of like chickens, right? Imagine I'm a farmer. I have a chicken. You're also a farmer. You also have a chicken. But maybe yours is healthier, right? Maybe I don't give a shit about my chickens and they're weak and small, but yours are like healthy and fat and like I would love to like have that, right? So if we exchange our chickens, it's not really the same thing. It's not the same thing as like exchanging two $1 notes. They're both different chickens with different properties, and one may be better than the other. So chickens are non-fungible, right? So NFTs, similarly, are non-fungible tokens. Can I check Slido once? Oh shit, I'm sorry. Huh. Is it best practice to use another MetaMask account or just completely use another browser with a new MetaMask? Yeah, you can just use a new MetaMask account. So I wouldn't recommend using the one you actually have money on mainnet. So like my main account, I have money on this account on mainnet, and I will never use this for smart contract development because if I accidentally leak the private key, if I accidentally like post it on GitHub or something, like I'm fucked, right? You don't want that. There will be bots who scan GitHub for leaked private keys and they'll steal all your money. So usually I suggest like I have a bunch of accounts on MetaMask and most of those are purely for like testing purposes. So I have just like these random accounts, account 9, account 10, account 11, whatever, and they don't have any mainnet money on them. I use them solely for testing and smart contract development, so I suggest you do the same. You don't need to use another browser, like it's the same thing, like just use another account. It's fine. Cool. All right, so where were we? Chickens. Chickens are non-fungible. NFTs are non-fungible. So let's look at what makes them non-fungible, right? Essentially, let's skip over all of this. Skip over all. And let me actually open the ERC20 standard on the side so we can compare. I feel like that would be helpful. So the first thing to notice is how transfers work, right? So in ERC20, this is the cryptocurrency standard, so these are fungible tokens. In fungible tokens, when you want to send money from yourself to someone else, all you need to do is you need to provide their address and you need to say how much money you want to transfer. You need to give a value, right? So you can transfer a value of 1, or you can transfer a value of 1,000. It's the same thing, right? That's kind of a property of fungible tokens. You can give me $1, you can give me $100. It's fine. In NFTs, in ERC 721, the way transfers work is you need to provide like a to address. So you need to provide an address for who you're sending to, but you also need to provide a specific token ID, right? So if you have an NFT collection that has like 50 NFTs, they're each going to have a unique ID. So like 1, 2, 3, 4, 5, 6, 7, all the way to 50. So you're going to have 50 token IDs. And all 50 of them are different from each other. Token ID 1 is not necessarily the same as token ID 2. It may be the same, but not necessarily. Typically, NFTs are not the same. Like that's the entire point of the standard. Otherwise, just use this one. So when you make a transfer, you also have to say which token ID you want to transfer, because it matters, because they're all different, right? Hopefully that makes a little bit of sense. Yeah, this line kind of wraps it up pretty nicely. So in general, all houses are distinct. No two cats are alike. So NFTs are all distinguishable from each other, and we need to track ownership of each one separately. So you need to track ownership of each token separately, and they're not the same thing. All right. Hopefully that was helpful. Let's get back to coding. All right. Cool. So, where were we? Okay, so we set up a new Hardhat project, right? So if you check out your VS Code now, or whatever you're using, let me zoom in a bit. All right. So if you look at your VS Code now, there's a bunch of folders here. So Hardhat made these folders for us. The main one we care about at the moment is contracts. So Hardhat created a, okay, this is too big. I can't work with this. Maybe a little bit zoomed in. Okay. So Hardhat created this contract for us. It's a pretty simple contract. All it does is it says hello. Anyway, this doesn't matter. We're gonna delete this file. We don't need this, but we're gonna write our NFT contract here. So get rid of greeter.sol. You don't care about that. Inside contracts, let's create a new file. Call it, I don't know. I'm gonna call it nft.sol. All right. Cool. So again, similar to the ERC20 tutorial, the cryptocurrency tutorial, since this is a standardized thing, ERC 721 is standardized, we don't want to reinvent the wheel. We can use a standardized implementation. And we're going to use OpenZeppelin because OpenZeppelin is amazing. OpenZeppelin is beautiful. So to use OpenZeppelin with Hardhat, previously on Remix, we imported OpenZeppelin contracts by just copy-pasting the GitHub link. But now we're working with Hardhat, and we're working on your local computer. So you don't get to just copy-paste GitHub links. Instead, OpenZeppelin also ships as a Node.js library. So you can just install that library in Hardhat and then use that. So to do that, let's, in your terminal, type npm install @openzeppelin/contracts. All right. So we'll type this and let it do its thing. Let me just Slido. What are those underscore before variables in function arguments? So underscores, they don't mean anything per se. It's just kind of convention. So typically, when you're writing code, actually, let me show it to you. I'm just gonna write some boilerplate here. So contract NFT. All right. So typically, when you write code, you have three types of variables. All right. You have global variables. Actually, sorry. You have two main types of variables that you care about. You have global variables and you have local variables. All right. So, like, in any programming language, you have these, right? So typically, it is just convention, and you don't need to follow this. There's like, it's totally up to the developer. It doesn't mean anything, but in these standards, all it means is when you're writing a local variable, it is convention to prefix it with an underscore, right? So if I have a variable here, which is like uint number, this is a global variable. But then if I have some function, just like, I don't know, which just returns a uint, and here I want to do public and returns a uint, and here I have like some local variable. It is just kind of convention to prefix it with an underscore. You don't need to do it. You don't need to worry about it. But it's just a variable name. Yeah. All right. Cool. I'll get rid of that. Cool. Where were we? Where's our terminal? All right. So installed opens up Lin contracts, and what it actually installed was like this GitHub repo. Well, specifically this folder. So installing the Node.js library for OpenZeppelin contracts gives us access to all of the contracts they have on their GitHub over here. So let's go ahead and use that. Before that, all right, I kind of skipped over this while I was giving an explanation, but you remember from last time, this first line is about telling Ethereum which Solidity version to use when running this code. Since smart contracts are not upgradable, yada yada yada, the Ethereum network has infinite support for previous versions of Solidity. Because if one day they decide, oh, we're going to stop supporting this version of Solidity, any contracts that were deployed in the past with that version just break. They just stop working. So they can't do that. So we need to tell Ethereum which version of Solidity you want to use for running this contract. So we're going to do anything over 0.8.4. And if you remember, we also need to add a license to Solidity contracts. It won't give you an error if you don't, but it'll give you a warning, which is kind of annoying. So yeah, let's just do this. All right, so what do we want to do in our contract over here? We want to create an ERC 721 contract, which is the standard we were looking at. And maybe we want to mint some NFTs for myself. All right, pretty basic. So first thing, we can import the ERC 721 contract that we just installed. So to do that, we do import and library name, so OpenZeppelin /contracts/ you can follow to find exactly where it is. Like you can sort of go on their GitHub repo, and if you see it's under like contracts /token /ERC 721 /ERC 721.sol. So this is what we want to import. So we'll just do /token /ERC 721 ERC 721.sol. All right. Cool. So once we import that, this is to import the standard implementation of ERC 721. And now we want to use this. We want to make our contract inherit from ERC 721. So we do is ERC721. So this says contract NFT is an ERC721 contract. So we're kind of like extending it. We're taking all of its functions and we're like, thank you for all of this. I'll add my own things on top of you. All right. And then we're going to create a constructor. So constructor is a function that gets called when you deploy the contract for the first time. So in the constructor, let's actually look at the ERC721 source code. All right. So ERC721 also wants a constructor. And if you were there for the cryptocurrency tutorial, or if you've done any of these levels before, you would know, like, if we're inheriting from ERC721 and we have our constructor here, we also need to call its constructor, right? Because it's like, if you see, I'm getting an error here right now, actually, because it's saying it should be marked as abstract. And the reason it's saying that is because I'm not calling the ERC721 constructor. Oops. All right. Any questions so far? All right. So to call the constructor, we just do ERC721. You write the name of the contract, and it wants two arguments from us. So the first argument is a name, and the second argument is a symbol. All right. And you'll see the error disappeared as soon as I added this. So name, I'll do LearnWeb3's NFT. And the symbol, I'll do Learn NFT. All right. So this is all we really need to create the ERC721 contract. So this part is done. The second part we want to do is we want to mint some NFTs for ourselves, right? So to mint some NFTs for myself, let's say I want to mint one. Let's take a look at the internal source code for this, and you will see that there exists a function called mint, _mint. Again, following the convention about underscore we just kind of talked about. So I talked about the convention in terms of variables. It is also a convention to prefix function names by an underscore when they are private functions, when they're not functions that can be called publicly or externally by someone else. When it's just a private function internal to the contract, or like a private function in a class, if you do object-oriented programming, there's kind of a convention to prefix that with an underscore. So you'll see this underscore mint function here is marked as internal, which means a user cannot call this. Only a function can call this. So a function in the contract can call this internally, but nobody from the outside can access this. All right. So since this is a function in the contract, we can call it here. So simply, if I were to mint one NFT to myself, I can just do underscore mint, and we see that it takes an address and a token ID, right? So we'll do message.sender, and let's start off token ID 1. I'll also note that it checks that it doesn't already exist. So at this point in the constructor, we know there's no NFT so far, so I can mint token ID 1 for myself. If I want multiple, let's say I want like 5, maybe I'll send some to you guys. Let's say I'll just mint a bunch of them for myself. Let's just do 5, right? All right. These won't have any value. These won't even have any images, but I'll send them to you if you guys want. Drop your addresses in Slido if you want these afterwards. Cool. So this will mint 5 NFTs to myself. Any questions so far? This is really all we need. At this point, you have a basic NFT contract. You will deploy it. It will mint 5 NFTs. You do whatever you want with it. It's not the most amazing NFT. It doesn't have like an image or anything, but by the technical definition, it is an NFT, and you can trade it on OpenSea or other NFT marketplaces. And yeah, it's pretty standard, pretty simple.
In sophomore, we have a more advanced NFT tutorial that has like a full website, and you can like, it has images, and every NFT has a different image, and people can mint it by paying with ETH, yada yada yada. But this tutorial is focused on getting you guys familiar with what is ERC 721, how to work with Hardhat, and um, how to like inherit contracts and use standard contracts, right? So we're not going to worry about all that bougie stuff right now. But any questions on what we have so far here? All right, so what IDE is best for Windows? VS Code works on Windows. I love VS Code. Um, I've only really used VS Code for the last few years, so I'm pretty biased maybe, but yeah, I love VS Code. At top, when I add the MIT line, it is a comment. So how does it recognize it? So the way it recognizes it is, first of all, it needs to be the first line in your contract, right? If I were to remove this from here and add it over here, you'll still get a warning. It will say your contract doesn't have a license. So first thing about how it recognizes it is it requires you to put it in the first line of the contract. Secondly, you need to follow a specific syntax. So SPDX is capital, and then you have a dash, and then a capital L, and license, and then dash, and then capital I, identifier, and MIT. So MIT is a type of license. There's a few different types of licenses you can use. That's out of scope for this video, but like you can look them up online if you want to learn the differences. But there's MIT, obviously. You can use Apache 2, 2.0, and there's a bunch of others. I actually don't even remember. But I think GitHub has a nice article on all the different types of licenses, open source licenses. So that's how it recognizes it, because it forces you to have it on the first line, and you need to write it exactly like this. Like, you can't have a white space here, you can't make this lowercase. It will still give you warnings. It will say that you don't have the line it's expecting. So that's how it recognizes it. All right, so are we using ERC 721 and building on top of it? Yes, that's exactly what we are doing. So 721 is a standard. If we look at the 721 code, it's a simple, well, it's not simple, but it's a standard contract, and then we are extending it because the ERC 721 contract doesn't mint tokens, it doesn't do anything with it, it just has all the functions you need to make an NFT contract. But by itself, it doesn't do anything. So we extend it so that we can actually like add features like minting of NFTs, and possibly other features in the future. All right. What are the two arguments for the ERC 721 constructor? So again, if we look at the code for ERC 721, it wants a name and it wants a symbol. All right. So let me actually try to show you an example. So a really famous NFT, obviously, Bored Apes Yacht Club. Everyone's heard of this, right? So Bored Apes, if you open up their contract on Etherscan, you will see this. You will see this token tracker here, right? And all it really means is that, similar to like cryptocurrencies, where you have a name and a symbol for cryptocurrencies, for example, like Bitcoin is the name, but BTC is the token, or Ethereum is the name and ETH is the token, right? So similarly, NFTs have similar conventions. So you have a name and then you have a symbol. So Bored Ape Yacht Club, the name is Bored Ape Yacht Club, and the symbol is BAYC, BAYC, right? So that's what it wants from us here. So we set the name to LearnWeb3's NFT, and the symbol is Learn NFT, right? What is the difference between 721 and the other ERC standard? All right. Let's see. So I explained to you the difference between fungible tokens and non-fungible tokens, right? Dollars are fungible, chickens are non-fungible. ERC 1155 was created as a way to kind of mix these two. All right. So an example is, what's a good example for this? Pokemon cards. All right. So Pokemon cards are different from each other. Like Pikachu is different from Charizard or whatever, obviously. So it's kind of an NFT, but like it kind of falls under what an NFT could be. But at the same time, it's possible to have two Pikachus which are the exact same, right? So there are parts of Pokemon cards that are fungible and parts of Pokemon cards that are non-fungible, right? All Pikachus are fungible. Like you can replace your Pikachu and my Pikachu; they're the same. It doesn't matter which one I have. But if you have a Charizard, I have a Pikachu. Like they're clearly different. It matters. So it kind of falls in the middle somewhere as like a love child of fungible tokens and non-fungible tokens. That is what 1155. So ERC 1155. Let's look at the standard there. So it's called a multi-token standard, right? ERC20, which was for fungible tokens, the token standard. 721 is the non-fungible token standard. And 1155 is the multi-token standard, right? It's like a love child of the two. So in 1155, what you can basically do is you can have multiple token IDs, which are different from each other. So you can have like token ID 1 is Pikachu, token ID 2 is Charizard, token ID 3 is Bulbasaur, whatever, right? But then you can also have multiples of the same token ID. So in 721, you can only have one token ID 1, right? You cannot have multiple token ID 1s. In 1155, you can have multiple token ID 1. So you and I, we could both actually have a token ID 1, and then 5 other people could have a token ID 2, and then 10 other people could have a token ID 3. In 721, that's not possible. In 721, every single one is different. You cannot have the same token ID owned by 2 people. In 1155, that's possible. So it's just like a love child of fungible and non-fungible tokens. Is that a BTC pillow up there? Yes, that is a Bitcoin pillow. It has the Bitcoin logo on the front, and on the back it says "Hodl me." Yes, you caught it. Perfect. Cool. I hope that explanation about 1155 makes some sense. I hope that's clear. All right. Let's get back to the code. All right. So far, all right, we wrote the Solidity contract, but on Remix, it was really easy to deploy contracts, right? You just go to the sidebar, you click deploy, and wow, it's deployed, right? Why would I want others to have the same token as mine? Well, again, like it's the example of Pokemon cards, right? Pokemon cards, like the people who created Pokemon, they wanted multiple Pikachu cards to exist, but at the same time, there were multiple Pokemons to also exist. So if Pokemon was an NFT game, if NFTs existed back in the day, like they would have used an 1155 standard, right? They wouldn't have used... Okay, you want a more relevant example? Here's this. LearnWeb3 NFTs, right? When we start giving out our NFTs, we're going to have 4 different types of NFTs, right? People who graduated from freshman, people who graduated from sophomore, junior, and senior, right? The graduates are going to get NFTs, but there's multiple graduates, right? So freshman and sophomore NFTs are different from each other, but there's not a single freshman graduate. There's hundreds of freshman graduates. So all of them are the same. So when we deploy our NFT contract, we're going to be using 1155, where we have 4 types of tokens, but there are multiples of each token, right? So that's the perfect use case of 1155. So Yeah. How are these numbered? Name them whatever you want, right? There are people who write these standards, who publish them, um, and like you give them whatever name you want. You give them whatever number you want. There is no reason 721 is called 721. There is absolutely no reason for that. For all they cared, they could have named it EIP 69 or EIP 420 and nobody would have cared. Like, there's no reasoning behind it. Um, it is totally up to the person who writes that standard what they want to name it. Yeah. All right. Cool. So anyway, where were we? Deployment. Remix is really easy for deployment. How do we deploy contractors in Hardhat? This contract is simple, but we're running on my local computer. How do I deploy? Actually, before deployment, let's try compiling our code and make sure there's no issues. So open up your terminal and let's type npx hardhat compile. All right. And if everything is okay, all right, compiling files and finished successfully. It's all good, right? No errors. Cool. And now let's talk about deployment. All right. First thing we want to do, since this is all based off of code, we will write a script to deploy our contracts, right? And this is more powerful than Remix. It may seem like, oh, this is so much more work than Remix, and Remix I just have to click a button. But it is actually more powerful than Remix when you get to more complicated contracts, right? Maybe in this example, it won't be immediately clear to you why writing scripts is better than clicking a button. But when you have really complicated code bases with like 15 Solidity files, all combining together to make a single contract, doing that manually on Remix is a huge pain in the ass. And that's when you want a script so that you just press a button, you write a command, you press enter, and boom goes your contracts. So it's good to get into the habit of doing it early. That's why we shifted to Hardhat so early, and you will see that like you will be grateful that you did Hardhat early on and you didn't stick with Remix. Cool. So to write a script, Hardhat created a scripts folder for us, and they have a sample script there. Let's not worry about that. Create a new file here. Let's call it deploy.js. This is a Node.js project after all, so we're going to be writing our scripts in JavaScript. All right. Let's start by creating a main function. So you're going to create a asynchronous main function because we're going to make network calls, and that's async. And then let's just call the main function. So if it succeeds, we just exit. If it errors, we will console error the error so we can look at it, and then we exit. All right. So in the main function is where we will do everything we want. So what do we want to do here? First, we want to, from the script, somehow figure out which contract we want to deploy. So figure out, actually, somehow tell the script we want to deploy the nft.sol contract. All right. Second thing we want to do is deploy it, right? Third thing we want to do is print the address of the deployed contract so we can go look at it on like Etherscan or whatever, right? Cool. Here's a little, actually, I'll get into this later. I have a bonus for you guys. Would creating a BSC contract be a similar build? Yes. BSC is Binance Smart Chain. So it is a fork of Ethereum that uses the exact same code as Ethereum, except it is significantly less secure than Ethereum, and as a result, it is faster than Ethereum with lower fees because security and performance, it's hard to have both of those together. So BSC, much less secure chain, but much faster chain than ETH mainnet. But BSC is still EVM compatible. It is still an Ethereum chain. So the way you develop contracts for it, the way you deploy contracts to it is exactly the same. The only difference is you're deploying to BSC instead of deploying to Ethereum. You just have to change one thing, and we'll get there shortly. But the Hardhat setup, writing the Solidity code, writing the deployment script, it's all the exact same regardless of whether you're deploying on BSC or you're deploying on ETH. Cool. So let's get started with this. So Hardhat comes with built-in support for ethers. Ethers.js comes built into Hardhat. Ethers.js is a really nice library to work with Ethereum smart contracts. Well, actually, to work with Ethereum in general, actually, not just smart contracts. So import ethers so we can use it. So in JavaScript, this is how you do, well, this is like old JavaScript. You do import ethers from Hardhat, and then let's do the first step. So somehow we want to tell the script that we want to deploy nft.sol. So you'll see the contract name is NFT, right? And Hardhat is beautiful, and Hardhat is smart in the way that it can automatically figure it out. So if you just have like if you just do like const contract equals await ethers.get contract factory and give it the name of the contract we want to deploy, Hardhat is amazing, and it will figure it out. It will know from the name that this is the contract you want to deploy. All right. So you write this line, and this will give you a contract instance. It will load up like the code of the contract and everything, so that you can deploy it. All right. The second thing we want to do, actually deploy it, is also really simple. So const deployed contract equals await contract.deploy. And I guess like as a subset, 2.1, you want to wait for deployment to finish because it can take a little while. So just do await deployed contract dot deployed. Was that so hard? This is pretty much all of the script right now. And then just for the third thing, just to print the address, we'll just do console.log NFT contract deployed to, and we will do deployed contract dot address. All right. Let me just look at Slido. I haven't looked at Slido in a bit. Yeah, I'm kind of getting questions mixed. Some questions on Slido, some questions on chat. I guess people have kind of given up on Slido, actually. All right. We tried something. People prefer live stream chat, so it's fine. All right. This is really all you need. This is super easy. All right. Now there's one more thing we want to do. When we call this, first of all, how do we call this? How do we start the script? Secondly, when we do call this, we need to deploy the contract from an address, right? When we used to do the same thing on Remix, Remix would ask you to connect your MetaMask to Remix. And Remix would ask you, when you try to deploy something, like let's say you go to Remix on this like pre-built contract, compile it, and so Remix, I've connected my MetaMask here, and it has my address. And then when I try to deploy something from Remix, it would pop open a transaction on my MetaMask. Okay, MetaMask's being kind of weird. It's not loading up. I don't know. I don't know what's happened to my MetaMask. Oh, there we go. So yeah, when you click deploy on Remix, it would pop open MetaMask and then you can confirm the transaction, yada, yada, yada. But we're not using Remix. We're developing on our local computer and we don't have MetaMask here. This is not related to your web browser in any way. So how does this know which account to deploy from? And also, how does it know which test network to deploy from? On Remix, it would choose the network based on what network you set on your MetaMask. So if I had set Rinkeby, it would deploy to Rinkeby. But again, this doesn't have MetaMask. This doesn't know which network you deploy to. So this is the last piece of the puzzle. And this is also related to the question about how to deploy to BSC. And all the magic is in this config file. All right. This is a sample Hardhat task. You don't need to worry about tasks right now. Let's get rid of that. Let's look at this configuration. Currently, it's super simple. It just tells which Solidity compiler do I want to use, and it defaults to 0.8.4, which you'll see I also use 0.8.4 when we were writing the code. But we can add a few more things here. So if we look at Hardhat user config, what does it need? All right. So Hardhat user config, we have currently defined the Solidity version. So we have a few open questions right now. How do we define which test network to deploy to? And then second is, how do we define which account to use for deployment? All right. So you'll see it takes a config option called networks, and networks is how we define which test network to deploy to. So let's add a thing here called networks, and let's say we want to deploy to Rinkeby. All right, say Rinkeby, and then it needs two things. So let's actually just worry about the first thing right now. This thing goes here, URL. So for those of you working with Hardhat for the first time, what the fuck is URL? You never had to worry about URL when you were using Remix, right? In Remix, when you deployed something, it just magically deployed it. But if you went through some of our first few levels on LearnWeb3, you would know that whenever we make transactions on Ethereum, whenever we do anything on Ethereum, we are talking to an Ethereum node, right? That node is running somewhere on a server or whatever. That node is running somewhere, and that node is what lets us interact with Ethereum, right? Here's something. So if I go to MetaMask and I go to settings and I go to networks, I have all my networks here. So say I go to Rinkeby. Look at that. We have a URL. So when you deploy something on Remix, it tells MetaMask to do a transaction. MetaMask has a URL for an Ethereum node to which it sends the request, right? On MetaMask, you sign the transaction. So like it signs it with your private key, and then the signed transaction, it ships it off to a server somewhere, which is running Ethereum node, and that then broadcasts it to the rest of the network. So all of this complexity is kind of hidden from you when you're using Remix, but don't worry, it will all be worth it. Hardhat will be very worth it. So you want an RPC URL. You want a URL for an Ethereum node you can use. In our tutorial, we suggest signing up on Alchemy. So Alchemy is a service where you can like create Ethereum nodes. So if you're running a If you're running a dApp that has like a lot of users, you probably want your own Ethereum node that only you can access. So you can direct all your requests there, and it's fast and it's easy. So when you go to Alchemy, once you log in, what you can do, you can go to create app, name it whatever you want. So I'll name it LearnWeb3 NFT tutorial. And I will select the development environment, Ethereum chain on the Rinkeby test network. All right. Oh, it wants a description. Whatever. Oh shit! I've reached the maximum number of apps. Okay. Okay. You can do this. You haven't reached your maximum number of apps. Do this. Create an application, and it will show up here like this. All right. And then you go into your application. Actually, let me just edit this. I'll switch this from being on mainnet to Rinkeby. I don't care. Yeah, whatever. All right. So, yeah. So you have an application. You go there and you click View Key. This will give you a URL you can use for deployment and everything else that you care about. All right. So that is your URL, right? Now I could just copy paste this here, but this is not secure because the other thing it actually needs here is the answer to our second question, accounts. How does it know which account to deploy from? So like whatever. This is like your private key goes here. If I were to just hard code this, if I were to just paste my URL and my private key here, and then one day I push it to GitHub, and everybody on GitHub now knows my private key and has access to my Ethereum node, holy shit, right? You don't want that. So we're going to use environment variables. So environment variables, for those of you who don't know, very quick explanation. It's kind of like setting values on your computer. So instead of setting values in your code, it is system-wide values that your code can read from, and it's typically more secure because like they're not hard coded into the code. So like when I push this to GitHub or whatever, all people will see is that I'm using an environment variable. They won't see the value of the environment variable. The value of it will be set on my computer, not in the code. All right, that's why they call it like environment, where we set in the environment. All right. So we need one last package to do this. We'll do npm install .env. Right. And the way people typically use environment variables is you create a file called literally .env, .env, and then we will set a couple of things here. So alchemy API key URL equals something, and private key equals something. All right. So I'll put my URL here. I don't care about this URL. That's why I'm doing it on a live stream. And obviously, I'm gonna not use my real private key. So if anybody wants to pause the video and try to steal money from me, go ahead and try to do that, because you're not going to get anything. I'm just going to use a fake account. All right. So, oh, let me show you how to get your private key, by the way. So I showed you how to get your URL. To get your private key, go to MetaMask and then switch to an account you don't care about. I don't care about this account. It has no money on mainnet. Switch to an account, create a new account if you need to, and then once you're there, click here, click on account details, and click on export private key, and type in your password for MetaMask, and this is your private key. All right, take that private key, throw it in here, and there you have it. All right, so we set up a .env file. And one thing we can make sure of is this git ignore. You will see we are ignoring .env file. So if I were to push this to GitHub, this end file will not go on GitHub because it is being ignored. So your secrets are safe. And the only thing that will go on GitHub is variables. So in the URL, instead of hard coding it here, I can just do process.env.alchemy API key URL. All right. So from my environment, get the value of this variable. And the variable is defined here, alchemy API key URL. And the same goes for private key. So for my private key, it's going to give it process.env.private key. And to read from the env file, we just installed .env. So we'll just add a line at the top here saying load.env and configure it. So that will automatically read the .env file, and then these values will work. All right. If there's any questions, post it in the chat. But that is all. We are finally done. All right. We defined a network. We have a URL for the node. We have a private key we can deploy from. We have the deployment script itself, and we have the contract itself. For the person who asked how to deploy on Binance Smart Chain in the past, the way you would do it is you could just add a second network here. Let's say like we call it like BSC, and then you can provide a URL for BSC, and you can provide an account for BSC. The only thing your account really needs to have is you need to have enough ETH or enough like BSC token to be able to pay for gas, so you can actually deploy the contract, right? And if you're using Alchemy, actually, I believe, oh, never mind. Alchemy doesn't support Binance Chain. But I'm sure there are other node providers you can get a URL for a Binance Chain node. And similarly, like if you guys were to do it on a different testnet, if you were to do it on Ropsten, only thing you need to do is like add like Ropsten, give it a URL, give it an account. Same goes for like mainnet or whatever. Like Alchemy supports 5 Ethereum networks, so 4 testnets and the mainnet, and then they support a bunch of layer 2s. We're not going to get into that right now. We're going to do layer 2s later. But yeah, all you need to do that is add a configuration object here, give it a URL, and give it an account. All right. So let us deploy our contract. This is what we've been waiting for. This is what the last 1 hour has been about. So to deploy our contract, we do npx hardhat run, because we're running a script, and then we give it the path of the script. So relative to the folder I'm currently in, it will be script/deploy.js, and then we tell it which network to deploy on. So the name of the network I have defined is Rinkeby, so I can do --network Rinkeby and hit enter. Let's see. Oh God. Whoopsie. Alright, what did I mess up here? This is live demos be like alright, what did I mess up here? This seems fine to me. Interesting. Ethers is undefined. That's fascinating to me. Alright, I'm gonna do some debugging real quick. This is what live sessions are all about. Alright, let's see. Why is ethers undefined? Ether should not be undefined. That's fascinating. Alright, beautiful. So Hardhat, Hardhat ethers, import it. I shouldn't need to do this. Did Hardhat get an upgrade? What version of Hardhat do I have? 2.8.3. Interesting. in the official tutorial, we have Hardhat version 2.8.0. Interesting. So they might have changed something in there. Okay. Well, let's check out Hardhat docs together. Let's see, maybe they updated their documentation if something has changed. We might need to update our tutorials now. That is interesting. All right. So let's see, quick start. Deployment scripts, where is scripts? Writing scripts. All right, so HRE, ethers. All right, so they just want us to import HRE like this now instead of ethers. All right, let's do it their way. Let's do it their way. All right. Wait, what do you mean extra comma? Where do you see an extra comma? Does MetaMask hide your private key if you do it through Remix? Yes. So that is the exact reason why MetaMask exists. So Remix doesn't get access to your private key. All Remix says is, hey, MetaMask, you have the private key. Can you please approve this transaction? Or rather, like, can the user please approve this transaction? You approve the transaction, and then you give it the approval to use your private key to approve that transaction, and then it goes off onto the network. So Remix doesn't ever get your private key. All right, you're saying I have an extra comma here. Where do I have a comma? I don't see it. Yeah, I think it's fine. I don't think there's an extra comma. All right, let's just do it their way. They want us to import HRE instead, and then use HRE.ethers. So we shall do just that. All right, that is annoying. Do I have a typo? Am I blind right now? No, this is not a typo. This is perfectly fine. What is going on? Does their sample script work? All right, their sample script is basically a deployment script as well. So if I just deploy our NFT contract here, let's see. So I don't know what possibly is going wrong here at the moment. That is very interesting. All right, so instead of deploy.js, let us do sample script.js at the Rinkeby network. Yeah, see, their deployment script, their script doesn't work either. Am I going, what is happening here? That is fascinating. All right, guys, live debugging session. All right. So let's see. Do we have HRE? Does HRE itself exist? Or is the import totally botched? All right. Oh shit, I was doing this before. Okay. All right, let's see if HRE exists. So HRE has a few things. All right. HRE, Hardhat arguments, tasks. I don't care about tasks. HRE.run, yes. All right, so it doesn't have ethers. Ethers is not here. Alright. Oh, I just Googled on my other monitor and I deleted a line that was here in the config file. I should not have deleted it. This is totally my bad, guys. Don't delete this line from your config file. This is what exposes ethers in here. All right, that's a lesson learned. I usually don't write JavaScript. I usually write TypeScript, so these errors are easier to catch. So this kind of threw me off for a second there, but I needed this line. It is unintuitive, I know, but had I not deleted it, it would have been fine. All right, let's start. Forget the last 5 minutes. It didn't happen. npx hardhat run deploy.js network Rinkeby. Let's go. Insufficient funds. Of course, I don't have money for it because I didn't request it from a faucet. So you need to request money from a faucet. Deploying a contract costs gas. So you can go to a website like rinkabyfaucet.com. Grab your... Oh shit, somebody stole money. This is a... Did any of you guys take my private key and steal the money from here? That is just mean, guys. All right. I will just send myself some money from a different account. I have a bunch of money. All right, I'll send myself 2 fake ETH. Please don't steal this. The problems of posting private keys on a live stream. Somebody just up and stole 0.1 ETH before I deployed. All right. That is beautiful. All right, so I have a couple of ETH now. Let's run the deployment script again. Guys, it's fake ETH. You don't get anything by stealing it. You know that, right? Like it's test network. It's not real money. Cool. So it worked. NFT contract deployed to this address. So let's copy this address and let's look at it on rinkeby.etherscan.io. All right. I'm going to paste this address here, search it up. All right. It can take a little while for Etherscan to catch up. Let's give it a while. There should be a transaction here for contract deployment. While we wait for Etherscan to catch up, any questions from anyone? All right, there we have it. Okay, so there we go. All right, Etherscan caught up. Let's look at this transaction. There's one transaction a minute ago. If we open it, we will see that a new contract got created. 5 ERC721 tokens were transferred because I minted 5 tokens to myself. So we have token ID 1, 2, 3, 4, 5, the ones I minted, going from the 0 address, which is the null address, to my address. Right? So I have 5 NFTs now. Perfect. And we can actually try to look at these. Again, this may not have synced already, but if we go to OpenSea, the largest NFT marketplace, and go to OpenSea testnets.opensea.io, I can actually copy paste this contract address in here. And here we have it, LearnWeb3 NFTs. And here we have 5 NFTs. As promised, they don't have any images on them, but we have 5 NFTs, and they're owned by the Hardhat test wallet. Like, that's just this wallet, this account that I'm using. And they were minted 2 minutes ago. I own all 5 of them. It is a real NFT. Oh, how do you get so much ETH on testnet? So there are a couple of different faucets. If you use the most common one, which is faucet.rinkeby.io, you can actually get up to 18 ETH, 18.75 ETH at a single time. The only thing you have to do to use this faucet is you actually need to like make a tweet So what you want to do is like you click this make a tweet button, right? And then it will open up your Twitter. And then you replace this null address with the address you're requesting the money on. So if it was me, I would copy this address. Oh wow, somebody stole my ETH again. Oh, that's beautiful. Love it, guys. Okay. All right. So if I make a tweet, replace the null address with my address, and click tweet. And then once the tweet is posted, my internet's being kind of trash at the moment. Sorry about that. There we go. So once the tweet is posted, copy your tweet link, put it over here, and then say, give me 18.75 Ether. So I actually recently requested it from somebody else. Oh, it looks like they don't have 18 Ether. They currently have less than that. Oh, wait, no, they do. Okay. Their faucet is having issues. Faucets go down now and then, but if and when that faucet comes back up, you can actually get like 18, 19 ETH from there in a single try. That is why I have so much ETH on me. It is faucet.rinkabee.io. All right. Cool. We have NFTs. We saw it on OpenSea. They don't have images attached to them, but we have NFTs. And we have 5 of them. And we did it all through Hardhat. Perfect. That kind of pretty much wraps up the tutorial. But to recap, we learned what is a non-fungible token, what is an NFT. We actually also learned what is ERC 1155, what is multi-token standard. We've made an NFT contract using 721. We minted ourselves 5 NFTs. We wrote a script in Hardhat to deploy the contract. We set up the Hardhat configuration file so you can deploy to Rinkabee, and I told you how to deploy to other networks if you want. We created an account on Alchemy, and I showed you how to get your API keys. I showed you how to export your private keys from MetaMask. I showed you how to use environment variables instead of hard coding your private key in here. And then we ran the script. We saw it on OpenSea. We saw it on Etherscan. And somebody was taking money out of my MetaMask. How did someone steal ETH from my MetaMask? So I showed my private key on the live stream, right? So if you pause this video and you take the time to go to your MetaMask, and then you go to import account, and you type this letter by letter, you do AC0974 yada yada yada, you type this entire thing, you will have my account, right? This is why you use test accounts for this stuff. Because if you accidentally show it to someone, you have it on a video, you post it on GitHub, the smallest mistake, and somebody has access to your account, and then they do whatever they want. I'm actually kind of happy. Like, it's funny for me. I'm kind of happy someone did that. So, like, it's like the perfect example of why you should use environment variables and why you should not use your main account that has money on mainnet on it for this kind of stuff. That is how they were able to take ETH out of my account, because I made my private key public. It is called private key for a reason, guys. Cool. All right. So yeah, we learned a bunch of stuff. I'm gonna take a look at Slido, and I am gonna, let's see. Oh shit, not this. I'll just open up LearnWeb3.io. Ooh, not this. Sensitive stuff. All right. Open up this and look at live chat. You can see where the money went, right? Yeah, I can see where the money went, but it's just like, it's just an Ethereum address, right? Like, I don't know. I don't know where they sent it. I don't know who it is. I don't really care, right? It's fake money. Like I really don't care. It is fake money. Um, I can get more test teeth if I need. Um, but yeah, guys. I am here to answer questions for a little bit. Um, I hope you guys liked the session. I know this was kind of different from the last one we did. Um, disrespect? Nah, it wasn't disrespectful. It's kind of perfect actually. Like it gave like a live example of why this stuff is important, right? How can you become a miner? Well, if you're asking for technically how do you become a miner, you download an Ethereum client and you run it. But I'm assuming your question is how do I make money by becoming a miner? Which we have an entire section on that. You go to it's in sophomore. You go to tracks and you go to sophomore on LearnWeb3. Our section on mining talks about who can become a miner, and it says technically anyone can become a miner, but not everyone can mine it profitably. Not everyone can make money. And this is because there is a lot of competition in mining, and your average laptop or computer is nothing compared to the types of computers and data centers that are set up for mining Ethereum or mining Bitcoin. So, unless you're willing to put a bunch of money into your mining setup, you likely cannot set up an individual miner that will make you money. Alternatively, though, you could start a mining node and join a mining pool. We have a small section on what is a mining pool here, and there are links to the top miners and the top mining pools. So go through this level. You will find the answers to all your mining related questions. Am I Hardhat on Discord? Yes, I am. That is me. Thank you. It was the first session. Like I appreciate it. Thank you for joining us. Um, really glad to have you here. This is awesome. The Mac setup makes my heart hurt. 0x. I don't know if you're still here. Why does the Mac setup make your heart hurt? Huh. You don't like Mac OS? Mac OS is so nice. Or do you not like my setup of my Mac OS? I don't know. Maybe. Is it because I'm using Microsoft Edge on my Mac? I get a lot of shit for doing that. People are like, why are you using a Microsoft browser on Mac OS? Like, hey guys, honest answer, it's actually so good. I can't hate on Microsoft for making a good product. It's better than Google Chrome, it's better than Firefox, it's better than Brave, Opera, whatever. It is not better than Safari. I actually really like Safari, but Safari has its own thing for how to make extensions for Safari, and then that leads to like MetaMask is not available on Safari, and I spend all day doing Ethereum stuff, and I need MetaMask, so that's kind of sad. But I really like Safari actually. How is Bitcoin different from ETH? That is kind of a long answer. It's also kind of out of scope for this session, but you can actually find the answer to this if you sign up on the LearnWeb3 website. Freshman Track has a level on what is Ethereum, and it goes over how Ethereum is different from Bitcoin. And if you want to go in even more detail about how exactly it is different from Bitcoin, you can look at things like the levels in sophomore about how gas works, what is proof of work, what is the Ethereum virtual machine, and that is like the lower level technical concepts on how Ethereum is different from Bitcoin. Um, Ethereum 2.0. That is such a long topic. I would suggest don't worry about it right now. Ethereum 2.0 is something we will have lessons on in the coming tracks. If you're still going through freshman or sophomore, trying to understand ETH 2.0 at this point will most likely confuse you. It's better to not be confused at this point, and we will teach ETH 2.0 once you have learned everything you need to know before you learn about ETH 2.0. Aussie, okay. How much more is involved in an NFT contract like Bored Apes, and how do they add features after creation? All right, that's a good question. So, our NFT contract clearly is pretty, like, we don't have an image and anything, so it is pretty simplified. In the sophomore track, we have a better NFT contract which has images, which has like other features where people can pay with ETH to mint the NFT, and we have a whitelist for pre-sale, and things like that. So there are other things. Bored Apes is a pretty simple contract. All it really did was, okay, we have 10,000 NFTs. You can pay like 0.08 ETH to buy an NFT, and you can buy a maximum of like 10 in a single transaction, right? Like it's really not that hard. If you look up Bored Ape contract on Etherscan, let me try to quickly walk you through their code. So Bored Ape contract Etherscan, their main contract is, let's search for it. So Bored Ape Yacht Club. All right, let's quick run through of their code, what they do. So in their constructor, they set a max NFT supply. So this is 10,000 because there's 10,000 Bored Apes, so they set it to 10,000. All right. They have a function called withdraw. Don't worry about this right now. They have a function called withdraw, which transfers all the money they made from their ETH sale to the owner of the contract. So like just transfer all the ETH to the owner. And then they have things like, okay, like reserve some apes for the team, and then set it in a single transaction. It wants that you haven't exceeded the maximum number of apes. So there's like, you're not exceeding 10,000 apes because of this transaction. And it wants that you've sent the correct amount of ether to be able to make this transaction. Once all of that is verified, then it just calls mint. So mint this token ID to this address, right? And then there's some like reveal related stuff, but really the chunk of it is this function, and they do the same thing. They just inherit from ERC 721. How you use it in the future when you make a game and whatever is smart contracts are non-upgradable, right? Like they can't make any changes to this contract now, but they can make a new contract entirely. And the new contract can use the NFTs from the old contract to do things. And that's how you like make a game in the future. The new contract relies on the NFTs from the old contract, and then it does things with those NFTs. So you have new functions, new code, new types of things that can happen. And that's how they build future stuff. You can't modify this contract after it's deployed. In LearnWeb3 tracks, no, we do not deploy NFTs on mainnet. I mean, if you want to, you can. Obviously, that would cost gas. All of our tracks, like we do testnet, it's meant to build your understanding. It's meant to teach you smart contract development and Ethereum development and help you become a Web3 developer. You don't need to deploy anything to mainnet. If you want, you can. Maybe if you want to learn whatever we have to teach you and then go out and we're like, I want to launch my own NFT collection. Go ahead, do it. Deploy on mainnet. Do your research, do your work. Deploy on mainnet, sell out, maybe make $1 million, get rich. Maybe give $500 back to LearnWeb3. No, I'm just kidding. But yeah, no, we don't ask you to deploy to mainnet. Obviously, that costs gas and that costs real money, and that's not what we're here for. We're here to learn, and that's what test networks are for. So you can just have fake ETH. All right, cool. I am gonna rug this live stream at 11:45. It's been going on for about an hour and 40 minutes already. I am hungry. I haven't had dinner, and I want to be respectful of your time as well. So, yeah, 5 more minutes to answer questions. This video will automatically end up on YouTube, but I will likely also edit it afterwards to get rid of the earlier, like, starting 10 minutes where I was just playing music and then the little Hardhat hiccup in the middle, and then re-upload it on YouTube as the edited video. But but yeah, I'm here for like 5 more minutes if anybody has any more questions, and then I'm gonna go eat some food. And yep. While you're here, if people are here for the first time, this is the first time you're hearing about LearnWeb3, make sure you're on the Discord. So if you go to the website, there's a button to join the Discord. Make sure you're in there. That's where all of this is planned. That's where people hang out together, learn together, and give us a follow on Twitter. We just crossed 8K on Twitter today. That is amazing. That is absolutely amazing. So if you haven't already, give us a follow on Twitter. Like literally yesterday, we posted a tweet about thank you for 7,000 followers, and today we have 8,000 followers, and that's absolutely amazing. Thank you guys so much. But yeah, you guys are great. Like it's fun hanging out with you. Oh God. All right. Cool. All right. Looks like there are no other questions at the moment, so I guess I can give you back for. Why is it fun exactly, dude? Okay. Dude, what do you mean we are noobs in front of you? Like, I was a noob. Like, everybody is a noob at something, right? If someone were to come up to me, I have friends who do like machine learning AI stuff all day long in their jobs, and I don't know anything that they do. I don't understand shit what they're doing. That doesn't mean that like I don't enjoy hanging out with them. Like I love it, right? You get to hear about new things. You get to hear about like cool stuff, and like I enjoy giving back to the community. I don't know. The blockchain community has been really friendly, given a lot to me over the years. So this is just kind of like I feel it's my duty to give it back to you. Like this is not work. This is hanging out with friends. That's what it feels like to me. So yeah, it is fun for me. I don't know. Where is the contract stored? The contract is stored across thousands of nodes in the world, running the Ethereum network. Ethereum is decentralized, so it is stored in a decentralized way. There's not one place where the contract is stored. It's stored across thousands of nodes across the world. So you're not relying on a single place. I am new to NFTs. It is great if you tell about it, starting it with Android. Android. I mean, it's pretty similar, honestly. The Solidity smart contract side of it is exactly the same. The only thing that's really different is how do you call smart contracts from Android. At LearnWeb3 in our courses, we teach you how to call smart contracts from a website, from like React or something. Um, on Android, if you were using React Native, actually, since React Native is also JavaScript, it would be literally the exact same thing as doing it on React, doing it on a website. But if you're doing native Android development, so if you're using like Java or Kotlin or something, there are libraries you can use. So for Java, there's this really famous library, Web3J, and you can read their documentation here. And Web3J is used to call functions to smart contracts and do all of those kinds of things, talk to the blockchain in Java, and it works on Android. So you can do that. How much time did it take for me to be good at Solidity? I don't know. I don't think. I feel like programming and tech in general is a field where every single day there's something new coming out. I have a. I don't know. I don't know. I don't. I don't. I wouldn't say I am good at anything because I know there's a lot that I don't know. There is so much. I mean, I don't know. I mean, like, sure, like I can code Solidity, I can code some contracts, I can build a DApp, yes, but I don't know. I've been doing Solidity on and off for a few years now. I feel like I know a decent amount. I feel like there's a lot that I don't know as well. So depends how you define good. I don't know. You can start building. I was building dApps and like taking part in hackathons and even winning hackathons like in a few months of starting learning Solidity, if that's what you mean. But yeah, I don't know. Depends how much time you put on it and how much background you have, I guess. Once deployed, do you need to keep the file on your computer? Is it irrelevant now? I mean, it is deployed, but like I did deploy it only to a test network, right? So maybe like if I want to make any changes to it, redeploy it, maybe deploy it to a different network, whatever. Um, like this is the development process, right? You deploy it to a test network and you like maybe make some changes, deploy it again. When you're confident, you deploy it to mainnet. Um, Usually, like I just push my code to GitHub, and then if I want, I can get rid of it from my computer because I have backups on GitHub. So yeah, I mean, I'll likely delete this because like I already have a copy of this code when I wrote the tutorial. But yes. All right, Aku, this is the last question I'm going to answer before I leave. So, how much time will it take for me to get a job in Web3? I'm a complete beginner in Web3, but have experience in other programming languages. So, if you have experience in the past in Web2, um, this was a question I answered earlier a couple of weeks ago. People have this misconception that getting a job in Web3 requires being an expert in Solidity. The reality is, most jobs in Web3 don't need you to write Solidity. All right? Think about it. Think about it. If you work at a company, let's say like a Web3 protocol, let's say you get a job at the Bored Ape Yacht Club, right? Maybe they want some developers. Do you think they're going to make you write Solidity? Like, why would they? Their contract is already deployed. Their contract is already on mainnet. You can't make changes to a contract that's already deployed. Maybe you can write some new contracts. Yes, that's a possibility. But Solidity is a piece of the puzzle. Solidity is something you need to know, something you need to understand. So you understand the Ethereum ecosystem and you understand how to work with it and you understand like how things are happening in the background. But most Web3 jobs, you will spend 90% of your time working on things that are not Solidity, right? You will spend your time working on the back end, which maybe interfaces with Solidity contracts, or it like does blockchainy things that some of the things we've already taught, some of the things we will teach later on. Or maybe if you're a front-end developer, you'll be building like websites which interact with the contract and do blockchainy things, but Solidity is a small piece of the puzzle. So how much time it will, I know Web3 companies who hire like good front-end engineers or good back-end engineers all the time who don't necessarily need to know Solidity. It is a big plus if you're familiar with the Ethereum ecosystem and you know how to use like Hardhat or like Ethers.js or all of these libraries that we teach, and you're familiar with like other tools like um, the Graph or Chainlink or like Connext and whatever, right? If you're familiar with the ecosystem, obviously it's a big plus for you. But my point is, your question about whether being good at Solidity affects that, I don't think so. I think it's a part of it, but it's not like being good at Solidity is not what will get you the job. Being understanding the ecosystem as a whole and being a good developer in general and practicing and like having experience building your own projects and going to hackathons and things like that, that's what will help you get a job, whether it's Web 2 or it's Web 3. The only difference is in Web 3 you're building the projects and you're going to hackathons specific to Web 3. In Web 2 you would build backends, you would build front ends, right? You would use the Google API or you would use like whatever other APIs. In Web 3 you're using Web 3 libraries, you're interfacing with Ethereum, you're using Hardhat, you're using Alchemy, you're going to Ethereum hackathons, yada yada yada. But the way you get a job is the exact same. Be familiar with the ecosystem, know the tools, have an understanding of how things are working, and you'll get a job. Yeah. That was a really long answer, and we're over time. I am more than happy to continue this train of thought further on the Discord. But yeah, we're almost at the 2-hour mark now, so I'm gonna rug this live stream for now. Ping me on Discord if you want to talk about this further. I'm more than happy to do it after I have dinner. But yeah, hopefully that helps. Love that yada yada yada. Yeah, I don't know where I picked it up. I use it a lot now. Cool, guys. All right. Thank you so much, everyone, for coming. Anyone has further questions, message me on Discord. I'll chat with you there. See you on the next one. Have a good night, good day, good afternoon. GM, sir. Bye-bye. I'll see you.